Why you didn't submit? Is there any specific reason or?
Sorry, sir, I can't hear you properly. Your voice is breaking.
Okay, am I audible clearly to you?
Yes, now you're clear.
So why you didn't submit the homework?
I submitted, sir. I submitted yesterday.
Okay, I didn't get it yet. Okay, thank you. Sorry. How many questions have you solved?
10, I think.
10. Is there any doubt in that? How many?
Yes, I had the second, no, the second calculation question. I didn't know how to start. It was too hard.
Just wait a minute. How many questions you have attempted? Total questions. Actually, you did 10 questions. And how many questions you have attempted? Just send me the question number that you had stuck, both of you,
Yes.
that you found difficulty. So solution it was right. Let me see. This solution. Question number 2.6. Right, Austin?
Yes, sir.
Okay, what about you, Humamuddin? So the question is not tough. Basically, it is lengthy and lots of calculation involves there. Just wait a minute. Let me copy the question from NCERT. Okay. Both of you able to see the question number 2.6 here.
Yes, sir.
So you can see in the question, how many ml of 0.1 m, capital M basically represents your molarity, are required to react completely with 1 gram mixture. That means Na2, there is a mixture of Na2 and NaHCO3 which has a weight of 1 gram. Okay. No, thank you, Humamuddin. Humamuddin, were you able to solve this question 2.6 or you haven't attempted this?
1 minute, sir. Let me check.
Okay. Let me just look into it. No, you haven't done this. So please
No,
concentrate. Okay, okay, got it. I got your solution. Now see, it has been given that HCl has a molarity 0.1 and there is a mixture of Na2CO3 and NaHCO3 and that mixture has a weight 1 gram. So I'm going to take, let the weight of Na2CO3 is M or X. I'm going to take because you'll be confused. Let's say this is X. So what will be the weight of NaHCO3? 1 minus X, because total weight of Na2CO3 and NaHCO3 is 1. So if I'm going to take the weight of Na2CO3X, then mass of or weight of NaHCO3 will be 1 minus X. Yes or no?
Yes.
Okay. Now what you need to do, calculate the number of moles of Na2CO3 as well as NaHCO3. So number of moles of Na2CO3 will be given mass, which we supposed it is X, and the molar mass, if you are going to calculate it, you will be getting 106. In the same way, you are going to calculate the number of moles of the sodium hydrogen carbonate or sodium bicarbonate. This will be equal to 1 minus X upon, if you are going to calculate the molar mass, you will be getting 84. Is that clear? Why I calculated number of moles directly? Because in the question, if you will see, it has been written that it is equimolar. What does this mean? Equimolar, that means same number of moles. These two mixture have same number of moles, and according to this statement, we can easily apply this. Number of moles of Na2CO3 is equal to number of moles of NaHCO3. I didn't write it. What we say? I just wrote this only because in the question it is given. According to the question, we can write according to the question. Now from here, you can easily calculate the mass X. How you can calculate? You can see X upon 106 is equal to 1 minus X upon 84. And from here, you can easily calculate the mass of X. Basically, not mass of X, value of X, which is mass of Na2CO3. And hence, you can see, you can easily calculate this. 84X will be equal to 106 minus 106X. Now, what you need to do, just move from right to left, the X part, and it will be 84X plus, there will be 106X will be equal to 106. And now what you need to do, you can see it will be equal to 190X will be equal to 106. And hence you can easily calculate the value of X. 106 divided by 190, which is approximately equal to 0.557 or 0.55, you can take. This is the X. X is mass. We took the weight of Na2CO3 is X. So it is 0.55 gram mixed with, you can easily calculate the mass of NaHCO3, which is basically mass of sodium hydrogen carbonate, which is 1 minus X, and 1 you know, and it will be equal to 0.55. I took approximation, so it will be 0.45 gram. We just calculated the mass of both. Is that clear?
Yes, sir.
Yes, sir.
Now, what you need to do, you can see how many ml of 0.1 m. We need to calculate the volume of 0.1 mHCl required to react completely with 1 gram. Do you know if HCl gonna react with Na2CO3? Okay, sometimes it doesn't. If HCl this is your HCl, and if you are going to react this with Na2CO3, then what you will get? Do you know? You will get 2 NaCl plus H2CO3 and if you are going to react this HCl with NaHCO3, you'll be getting NaCl along with H2CO3. And here you can see, to balance it, you are going to multiply it by. Are you getting my point?
Yes, sir.
Yes, sir.
Now, what you need to do, total number of moles HCl used, you can see 2 moles of this react with 1 mole of this, right? And 1 mole of this react with 1 mole of this. You just calculated the number of moles. So accordingly, you can easily do this as well. Whatever is the we can do like this. This is your 2m molarity. Then this will be your 1m. And hence, since it is your, or just let me look at the question, NaCl H2CO3. Wait a minute. Okay. Now what you need to do, it's very simple. Whatever is the number of moles, number of moles here of Na2CO3 is 0. What was the number of moles of Na2CO3? Just wait a minute. Number of moles of Na2CO3. Sometimes number of moles of Na2CO3, that is given mass X upon 106. I wrote it. So what was the value of X? 0.55. 0. Just wait a minute, please. But my pen tab is not working smoothly. Now I pay attention. So this will be your basically 0.55 upon 106. This is the number of moles of Na2CO3. Along with, you can easily calculate the number of moles of NaHCO3. Which is 1 minus X. That is equal to 0.45 divided by 84. And you can get this. This is your number of moles. Now what you need to do, it's very simple. To neutralize this solution, we need 2 into number of moles of Na2CO3, which is 0.55 upon 106. Plus you can see this is your 1 mole 1:1 ratio. So it will be as it is 0.45 upon 84. So total moles you can easily calculate from here. Total moles. So this, after calculating this, you will get total moles. Now what you need to do, it's very simple. Molarity is given as 0.1 m. Total moles you just calculated from here, number of moles, total moles. And then what you need to do, molarity is equal to what? Number of moles of solute upon volume of solution in liter. And we need to calculate volume. Volume will be equal to whatever you calculated, the number of moles, total moles upon molarity is given 0.1. You can easily get the volume. Is that clear?
Yes, sir. But why do you multiply with 2?
Because the molar ratio, you can see this is your 2 and this is your 1. That's why here it is only 1:1 ratio. Is that clear?
Yes.
Can I change the slide? Next question, just wait a minute. Please do write. This question is not that much tough, but calculations is quite difficult here, which is also easy. Multiply, divide. In physical chemistry, you will be getting this type of questions if they want to make it look tough. Everyone done with this? Yes or no?
Yes.
Also,
Okay, take your time. Only these questions you have doubt in, Austin?
Yes, sir.
so could you scroll down a little?
Yeah. So from the starting, if you are going to solve all the NCERT question, it will be very helpful, and you are going to do it by your own. And if you get doubt, I will be solving here, clear your concept, but you have to revise this again and again.
And done.
Okay. The next question Humam asked is, this is your question number 8, right?
Yes.
Question number 8. What about you, Austin? Did you solve this? Actually, I didn't get your
Yes.
solution.
Yes, I did.
You did. Okay. Okay, so this is quite easy. Just wait a minute. Okay. So you can see that antifreeze solution is prepared from 222.6. Triple 2.6 of ethylene glycol, which has a formula C2H6O2, and 200 gram of water. They are mixed and prepared a solution, which is antifreeze solution. Calculate the molality of the solution. If the density is this, then what shall be the molarity of the solution? They also ask about the molarity of the solution. Okay. So what I'm going to do, it's very simple. You can see we need to calculate molality. As you know, first of all, whenever you look at the question, you are going to write whatever is given. So I'm going to write mass of ethylene glycol. I'm going to represent it with a small e, which is given as 222.6 gram. And it is also given that mass of water, that is H2O, is given as 200 gram. Now, also, it's given that the density of solution is what? 1.072 gram per ml, right? Gram per ml. Now, it's very easy to solve the question. First of all, we are going to calculate the number of moles. Now, first of all, what you need to do is very simple. First, what you need to calculate first? Molality. What is the formula of molality? Molality has a formula. Number of moles of solute. Solute and solvent is very important. If you don't recognize it, you will definitely do wrong. Number of moles of solute and mass of solvent or weight of solvent in kg. So first of all, let me know, Umamuddin, you have two components. One is your ethylene glycol and another is your water, which is solvent. What do you think, Umamuddin? Austin?
Ethylene glycol.
Ethylene glycol is your solvent or solute?
Solvent.
I told you the one which is larger in amount is solvent and the one which is lesser in amount is solute. So for which we are going to calculate the number of moles, it's very simple. For water because it is the solute. So number of moles of solute, which is given mass 200 and molar mass will be 80. And approximately it will be 11.11. This is your number of moles. Now you know that molality has this formula. So I'm going to apply number of moles of solute. You can see this will be 11.11 divided by mass of solvent, which is 22.6 divided by 1000. And if you are going to calculate it, this will be in kg. That's why I divided this 222.6 divided by 1000 because we need to keep the value of mass of solvent in kg and you will get your molality. Is that clear, everyone?
Yes.
Now, what you need to do for molarity, you know that number of moles of solute upon volume of solution in liters. So it's very simple, as you have calculated the number of moles of solute, because in this solution the solute is your water and you have already calculated the number of moles of solute, which is 11.11. Now we all need to calculate the volume of solution from the given data. Now density is given. Density is what? Density is given as 1.072 gram per ml. And mass of the solution you can easily calculate. Mass of solution will be equal to mass of solute, that is your 200 gram of water, and triple 2.6 is your solvent, And after solving it, you will be getting 422.6 gram is the mass of solution. Now, what you need to do, you know that density is equal to mass upon volume. So density of solution is given here, and mass of solution I just calculated, put the value of D and M here. You will be getting the volume of solution in ml. Whatever you have got the value of solution in ml, you are going to put the value V divided by 1000, and then you can solve it. You will get your molarity. Is that clear, Humamuddin?
Yes, sir.
Okay, please do write it and let me know. Let me check the next question.
Yeah, done, sir.
Just wait a minute. I'm gonna copy it to the. So this is your question number 2.1. The question is also quite easy. Austin, have you solved it?
No, sir. I didn't.
Okay. Okay, okay. No problem. 2.1. Calculate the mass of non-volatile solute. Its molar mass is given as 40 gram per ml. Whatever is the solute, it is non-volatile. We need to calculate the mass that you have added in a volatile solvent or solvent, which should be dissolved in 114 gram of octane. That means this is your solvent, and the solvent is octane. Octane, that means the formula will be C8H18. Octane, you know the formula of octane, right? Yes or no?
Yes, sir.
Yes, sir.
To reduce its vapor pressure to 80%. In the class, as I already explained, when you are going to dissolve non-volatile solute in a volatile solvent, the vapor pressure decreases. The vapor pressure decreases. Okay. So you can see you added some non-volatile solute in a volatile solvent of 114 gram octane, and it reduces its vapor pressure to 80%. That means whatever is the vapor pressure of the pure solvent, it reduces up to 80%. It reduces to 80%. So I'm gonna let the vapor pressure, that VP of pure octane or pure solvent, you can take pure octane, be P naught. Let's say it is P naught. So according to the question, the vapor pressure decreases up to 80%. Vapor pressure, to reduce its vapor pressure to 80%. That means 80% of the P naught. 80% of the P naught. That means you will be getting 80 P naught by 100. That means the new vapor pressure is 0.8 P naught. Is that clear up to this? Is that clear?
Yes, sir.
Now, see what you need to do. As you know, the molar mass of non-volatile solute, I'm going to take as M2, is 40 gram per ml. That is given 40 gram per ml. Sorry, 40 gram per mole, not ml. And molar mass of octane, that I'm going to take 1. This is for octane. I'm going to write here. And this is for non-volatile solute. Always remember, if you are going to solve this in board, you have to show whatever you are taking as that, like M2, M1. What is M2, M1? You have to write it Okay. M1 is your 114 gram per mole. You can easily calculate 8 into 12 plus 18 into 1, that will come out to be 140. Now, if you remember this formula, P naught minus pressure of the solution upon P naught, wait a minute, upon P naught, this was the formula, will be equal to the mole fraction of solute. If you remember, do you remember this formula? Yes or no? This is the relative lowering in vapor pressure. Do you remember this formula? Austin and Humamuddin.
Yes.
Yes, sir.
Now it's very, very simple. This is your molar mass. As I already told you, this is your molar mass. Okay. And one more thing is that mass of octane, given mass of octane is 114 gram. That is given in the question. Now, mole fraction of the solute has a formula: number of moles of solute upon number of moles of solute plus number of moles of solvent. Yes or no? Are you aware of this?
Yes, sir.
Now, here comes the important concept of this question. Now, I'm going to write this P naught. We took the vapor pressure of pure solvent as P naught. What is the vapor pressure of the solution we calculated? It will be 0.8 P naught divided by, this is your P naught. So I'm gonna solve the left part first. You can see you will be getting 0.2 P naught upon P naught upon P naught. So P naught can easily be cancelled. You can see P naught can easily be cancelled. Now, on the right hand side, if you are going to see, you know what, the volatile solute generally we mix is very, very small or very less in quantity. So we generally neglect this, because if you are going to add a very small amount of solute in a very big large amount of solvent, so it will not affect that. That's why we neglect it. Are you getting my point?
Yes, sir.
Now, what you need to do? It's very simple. What is the formula of number of moles of solute? Solute is your, I'm going to take this as given mass of solute upon molar mass of solute, 40 is given. Now, this is the solvent, given mass of solvent, 114, and molar mass of solvent we calculated, that is 114. This will be cancelled. Now, if you will see it carefully, you will get to know this will be equal to 0.2, that will be equal to m by 40. And if you are going to solve it, you will be getting as 8 grams. So this will be the mass of non-volatile solvent. Is that clear?
Yes, sir.
Yes, sir.
Okay. Let me know when you are done with this. Done all of you,
Yeah, done, sir.
both of you. Okay, the next question comes from photo 2.33. Just wait. So, what's your ambition, both of you? Can you share this? Mamuddin,
Yes, sir.
what's your ambition? What we call it? What do you want to do after class 12? Just class 12, after class 12. What's your aim?
I'm not sure, sir. I haven't
You
decided.
haven't decided. Okay. But still, if there anything like you have maths, right?
Yes, sir.
Okay. So will it be engineering or something else? What about you, Austin?
Probably doctors are not really sure.
I didn't get it. Sorry, come again.
Probably something in medicine.
Medicine. Before that, what is that term?
Something in medicine.
Okay. You also have maths, right?
Yes, sir.
Okay. You want to go in medicine, like research.
That I'm not sure, sir.
Okay. Okay. Let's and how much you are
So I think you're lagging.
wait a minute. Is the screen visible to you?
Yes.
Okay. So this is the last question that you have asked, 2.33, 33, question number 33. And 19.5 gram of this compound is dissolved in 500 gram of water. So this is your solute for sure, and this is your solvent. Water is your solvent here. Now, the depression in the freezing point of water is 1 degree centigrade. That means delta TF is given as 1 degree centigrade. Now see, calculate the Van Hoff factor and dissociation constant of fluoroacetic acid. Don't go for this directly. We are going to focusing on this Van Hoff factor. If you remember, I had written a formula of this. Delta TF is equal to I into KF into M, right? KF into M. Is that clear?
Yes, sir.
Now see what you need to do. It's very simple. Delta TF is given as 1. And I we need to calculate. KF, it should be given, but in this question, KF is not given, right? But KF for water, we know that it has a value 1.86 Kelvin kg per mole. Kelvin kg per mole. So it will be equal to 1.86. Now all we need to do is to calculate molality first. Molality is number of moles of solute. You know that number of moles of solute upon mass of solvent in kg. Mass of solvent in kg. Number of moles of solute, you know, given mass upon molar mass. So this is the solute, given mass is 19.5, and molar mass we can easily calculate. 2 carbon is there, so it will be 24, 12 into 2, 24, and How many oxygen is there? Two oxygen is there. So one oxygen 16, it will be 32 plus how many hydrogen? Three hydrogen is there, as well as fluorine, that is almost 20. So the molar mass will be approximately equal to 35, 55, 65, 75, 79, approximately how much? 79. Are you getting my point? Yes or no?
Yes.
So you can easily calculate. Oh, wait a minute. We need to calculate the Van Hoff factor, right? Just wait a minute. This will be 19. 19. So the molar mass is 78. And after this, you are going to divide it by mass of solvent, which is 500 gram. If you are going to convert this into more kg, it will be divided by 1000 and it will be like this. So this is your molality equation. Molality equation will be, again, I'm going to simplify it a little bit. 19.5. Just wait a minute. 19.5 upon 78 into 2. And if you are going to solve it, you will get the molality. You are going to put the value here, and then you can easily calculate the value of I. Is that clear?
Yes, sir.
Now, how you are going to calculate the dissociation constant? Since this is your acid, so we can call it acid dissociation constant as well. So first you are going to write it. Then I'm going to talk about this dissociation constant. Are you done with this?
Yes, sir.
Okay. So dissociation constant comes from class 11, which is quite easy if you're going to see. This is your CH3F and C double O. And if you are going to dissociate it, you will be getting CH3F C double O negative, and this will be your H plus. Now, if you are going to look at T equals to 0, let's say this is your C, concentration C, and here the concentration will be 0, 0, and this is your C mole per liter. Now, if you are going to subtract after some time T equals to T, it will be dissociated into its sign. So it will be C minus C alpha, and here it forms C alpha and Cl. C alpha and Cl. Now, what you need to do, it's very simple. You are going to apply the formula for K. K is equilibrium constant, and for this, since it is an acid, we are going to write this is your acid dissociation constant, in which you know this will be equal to molarity of this CH3F C double O negative H plus divided by CH3F C double O H. And accordingly, you can put the value of this C alpha. This has the value C alpha, and then C alpha again for this H plus upon. Here you can see C minus C alpha, that can be written as, if you are going to take C as common, 1 minus alpha is there. So this will be C into 1 minus alpha. And you can easily calculate the value, because this will be equal to C, and one of the C will be cancelled, and here you will be getting C alpha square upon 1 minus alpha. Now 1 minus alpha is there, and you can easily calculate the value of C. C is molarity, and molarity from the information given, number of moles upon volume of solution, you can easily calculate the C. Now how you will get alpha? Alpha is very easy to calculate, since I is equal to after dissociation. After dissociation, how many moles? C plus C. This is the after dissociation. This whole quantity is the after dissociation. This will be C minus C alpha plus C alpha, and then again C alpha divided by initial moles. You can see C is there, so you are going to put it in this, and this will be cancelled. And what you have got, C plus C alpha. If you are going to take C as common, it will be 1 plus alpha upon C, and you can see that I has a value that you will get 1 plus alpha. I is equal to 1 plus alpha, and you already have calculated the value of I in the first equation. You can put it here and you will get the value of alpha. So you are going to put the alpha value of alpha here, and you can calculate the molarity. You are going to put it here, and you will get the Ka. The question is of physical chemistry, so there will be calculation, and in this question, calculation is there. So please do write it. I did it incompletely, incomplete, intentionally. You are going. I did it incomplete intentionally, because you are going to complete it. Is that clear, both of you?
Yes.
Yes, sir.
So can I change the slide? Just let me know when you are done with this.
Done, sir.
Very good. Just wait a minute. Now I'm going to give you a question like this. Will you be able to do this? Mahmoudin, you haven't done any theoretical question.
Sorry, sir.
Wait a minute. Will you be able to do this type of question? Both of you.
Yes.
Yes, sir.
Okay, please do it. Okay.